Hi, this is the homework, students, from Monday, 5-6, composite figures. And so I'll go through the problems and maybe you'll have some help for tonight. Okay, this is a parallelogram. The area of a parallelogram is equal to base times height. Well, the base is 14. If we're going to look at this height, it's the height between these two sides, so the base is 14. This is a 45, 45, 90-degree triangle. So if this is 12, this is the hypotenuse, then this is 12 over rad 2, which can be simplified to 6 rad 2. So the height is 6 rad 2 and the base is 14. So the area is equal to 84 rad 2. Number 2, to find the area of this triangle, and it can get confusing if you don't remember that this is the triangle we're looking for the area of. Area equals 1/2 base times height. The base of this triangle that this height is drawn to is this base right here, 10. The height happens to fall outside of the triangle. It's 1/2, base is 10, and the height is outside times 8. So that's 5 times 8 equals 40. Number 3, the area of a square is equal to s squared. This is a side of 5, so area equals 5 times 5, which is 25. I have two number 3s. This one. This parallelogram, the area is equal to, again, base times height. This base is 18, so this side is also 18, and this is the height between them. This is a 30, 60, 90-degree triangle over here because this is 60 and this is 60. So if the hypotenuse is 12, then the short leg is 6 and the long leg is 6 rad 3. So I now know the height, so I can multiply the base of 18 times 6 rad 3, the height. And 18 times 6 is 108. So this is 108 rad 3. Number 4, the height of a parallelogram is 12. The area is 168. Find the base. Area equals base times height. So 168 is the area, and that equals 12 times the base. Well, to solve for the base, I divide both sides by 12. And 168 divided by 12 is equal to 14. Number 5. Here is a rhombus, and the rhombus has, we're given the diagonals. So we're going to use the area of a rhombus to equal 1/2 diagonal 1 times diagonal 2. Diagonal 1 is 9 plus 9, which is 18. Diagonal 2 is 11 plus 11, which is 22. And we're going to multiply that all by 1/2. So 18 times 22 is 396 times 1/2 is 198. So the area of this rhombus is 198. Number 6. Here's a rectangle. This is a right angle, and these are all, this should actually have 2 tick marks maybe to make it more accurate. So this is a rectangle, and it has a diagonal of 12. And this is 60 degrees, so this is a right angle. This is a 30, 60, 90 here. To find the area of this rectangle, we need base times height. So we need to find the length of this side and this side to find the base and the height. The hypotenuse is 12 over 30, 60, 90. First side we find is the short side. The short side is half of that, so that's 6. The long side is 6 rad 3. So the area of this rectangle is equal to 6 rad 3 times 6, base times height. And that's equal to 36 rad 3. Number 7. Here's a composite figure. We have to decide where to divide this figure so that we can find the areas of figures that we know, basic figures. And if we draw a height here, make that 90 degrees, then we can divide this piece of the figure into a rectangle, and this piece is a triangle. If this side of the rectangle is 5, then this side of the rectangle is 5. If this side of the, this is actually also a trapezoid. I could be looking at this as a trapezoid also. I just realized. In fact, I think I'm going to do that because it's a lot faster. So the area of a trapezoid is equal to 1/2 times the height times base 1 plus base 2. And I have all the information I need here. I have base 1 and base 2. And I have 5 for the height. So I can solve. Area equals 1/2 times 5 times 10 plus 18. So that's equal to 5/2 times 28. And I can cancel, and I get 5 times 14, which is 70. So the area of number 7 is 70. You could do it breaking this into a triangle and a rectangle as well. Okay, number 8. Number 8 is also a trapezoid. So I'm told that the area is 55, but I need to find the height. So again, area equals 1/2 base 1 plus base 2 times the height. That's equal to 1/2. Base 1 is 8. I'll call that one base 1. It doesn't matter. Base 2 is 14, and I don't know the height. But I do know the area is 55, so I can plug that in there. And then I have enough information to solve for h. So 55 equals 1/2 of 22. Well, that's 11. So 55 equals 11h. So h equals 5 if I divide both sides by 11. So I found the height of this trapezoid. It's 5. Number 9. The area of a kite is 120 meters squared. The length of one diagonal is 15 meters. Find the length of the other diagonal. I don't really even need to draw a picture for this. I know the area of a kite is 1/2 diagonal 1 times diagonal 2. The area of the kite is 120, and that's equal to 1/2 times 1 diagonal is 15. What's the other one? Okay, so I have 120 equals 1/2 times 15 d1. I'm going to multiply everything by 2 to clear the fraction, and I get 240 equals 15 d2. To find d2, I'm going to divide 240 by 15. And I get 16. Just to check, I'm going to multiply. Diagonal 1 is 16, and diagonal 2 is 15. I multiply those together and divide by 2, and I do get an area of 120. Okay, number 10. Number 10 is to find the circumference in the area of the circle given this radius 6. Area equals pi r squared. Area equals pi times 36. 6 squared is 36. There's the area, and that's exact. Circumference equals 2 pi r. Circumference equals 2 times pi times 6. That's 12 pi. So the circumference equals 12 pi. Number 11, we want to find the exact area of the shaded region. So to do that, I'm going to find the area of the whole circle and then take out or subtract and that will leave these edges. So the circle minus the area of the square. I'm told that the circle has a radius of 6, so the area of the circle is pi r squared, and so that's 36 pi for the area of the circle. Now the area of the square is going to be equal to s squared, but I don't know the length of the side yet, but I can find it. Just 1 second. Just gotta fix something. Okay. So if this angle here is a 90-degree angle, and these two sides are radii, then this is 6 and this is 6. This is a 90, this is a 45, 45, 90-degree triangle. So I can find the length of this side. This leg is 6, this leg is 6, the hypotenuse is 6 rad 2. So this side, where the hypotenuse of that 45 is 6 rad 2. So the area equals 6 rad 2 squared. That's equal to 36 times 2, which is 72. So I can take the area of the circle, 36 pi, and subtract 72 from it. That's the area of the square, and that is the area of the edges left over. Number 12. Here's a composite figure. And we can divide this into two basic figures. I'm going to divide it here. We're asked to find the perimeter and the area. Okay. Well, I'll find the area first. The area of this rectangle is 7 times 20, right? It's base times height. So 20 times 70, that's equal to 140. And then the area of this rectangle is equal to, well, here's a base, but what's the height? Well, if this whole side is 16 and this side is 7, then this is 9 right here. And so this is 9. But let me make this a little clearer. This whole thing is 16, but this little piece in here is 9. Okay, so this area is 9 times 11, which is 99. So I can just add together 140 plus 99. And I get 239 for the area of this composite figure. And I have almost all the sides I need to find the perimeter. 7 plus 20 plus 16 plus 11 plus 9. What's this side right here? Well, if this whole side is 20 and this side is 11, then this side is also 9. 20 minus 11 is 9. So I have my perimeter as 7 plus 20 plus 16 plus 11 plus 9 plus 9. And that's equal to, let's see, 27 plus 27 is 54. 54 plus 18, and I get 72. That's the perimeter. As always, if you see an error, please let me know. Okay, number 13. Here's another composite figure. And with this dotted line, we can divide it into a rectangle and a triangle. The area of this rectangle is base times height. So it's equal to 12 times 8, which is 96. So the area of this is 96. And the area of the triangle, we're going to need the base and the height. Let's draw it in. Well, the base is equal to 8. So the area is equal to, of a triangle, is 1/2 base times height. So if the base of this triangle is 8, the height, let's look at the height. This whole side is 16, this whole length of this figure, I should say, is 16. And if we subtract 12 from it, what we'll be left with is 16 minus 12, we'll be left with 4. So the height is 4. So we can just multiply this as 1/2 8 times 4, and that's 16. So the area of the whole figure is 16 plus 96, which is equal to 112. And that's the area of that composite figure. Here we have a square. I can tell because these three sides are all congruent, and this side, it's a square. And this is a half circle being taken out of it. So we're going to find the area by finding the area of the square and subtracting from it this half circle that's been taken away from it. So the area of the square, of course, is side squared. So that's 100. The area of the circle is going to be area equals pi r squared. We're going to divide that by 2 because it's half of a circle. So pi, and what is the radius of the circle? Well, if this side is 10 and this side is 10, then the radius of this circle here is 5. So that's pi times 25 over 2. So the total area is equal to 100 minus the area of the whole square minus the area of that half of a circle. That's why we have it divided by 2. The perimeter is the distance around, so it's from here to here, to here, to here, to here, to here, and down and around. So I know that this is 10, and this is 10, and this is 10. So I know it's 30 around from here and around all the way around here, but I need to find what the circumference of this circle is and take half of it. So it's going to be plus, the perimeter is 10 plus 10 plus 10 plus the circumference. So circumference is equal to 2 pi r. The radius of that circle is 5, so that's equal to 2 times pi times 5. So that's equal to 10 pi. However, we have to divide it by 2 because it's only half of the circle. So the whole circumference is 10 pi, 2 times pi times 5, but the whole, half of it is 5 pi. So the perimeter is 30 plus 5 pi. And that is the perimeter for this figure. Okay. I hope to see you tomorrow. Hope you have a great night. Bye.